We've looked at the idea of exponents and also the idea of radicals, but how do they relate to each other? Well, I try to remind my students that if you can look at the square root of x and remember that that translates to x to the 1/2 as an exponent, and this is what we call a rational exponent because it's a fraction, then all of the other rational exponents and radicals you should be able to translate. Remember, a square root has an understood 2 out here, and this x has an understood 1. So that translation comes to the inside value becomes your numerator, and the outside value becomes your denominator. As another example, consider something like x to the 4/3. When I set up my radical, the 4 is going to become my numerator, and the 3 is going to become my index. But we remember from our simplifying rules that we can't have an exponent inside the radical that's greater than the index. So we're going to take that exponent 4, divide it by the index. 3 goes into 4 once, with a remainder of 1, which tells us to pull out an x and leave 1x underneath. Just as another example, consider something like the 5th root of x cubed. If we want to translate that into a rational exponent, our numerator comes from inside and our denominator comes from the index. The same concept can apply when we're using numbers. So for example, if I'm looking at the 6th root of 400, that is 400 to the first, so I can rewrite this as 400 to the 1/6. But notice that 400 is really just 20 squared to the 1/6. But remember our rules of exponents, we can raise this power to a power by multiplying these two, which leaves us with 20 to the 2/6 or 20 to the 1/3. And then we can translate back to a radical form and we get the cube root of 20.